So I saw one of these resistor boxes on the EEV blog channel, and it's pretty good. It works quite well. So we can do 10k increments. We can do 1k increments, 100, and we can go down to 10. I'll have to switch my range. 10 ohms, 20, 30, all the way down to 0.1 ohms, which my meter, as you can tell, it's measuring sort of 2 ohms already. Doesn't really have the accuracy for 0.1 ohms. There's quite an interesting construction. It's definitely made to a price point. So these binding posts are particularly cheap. So one very simple upgrade would be to replace these with some nice fancy binding posts that have the nice push wire connectors. But let's take a look at the actual construction and see what we can do with this. I've taken it apart once already, and you can hear the rattling of the screws inside and my dirty fingerprints because there's a bit of grease on the buttons. But if we pop this open, you can see the quite interesting construction. So one of the interesting things is that they've got away with just using 6 resistors on each of these sweeps. So if we look at, say, the 100 ohms, it's currently on 0. So you can see it's currently connecting directly from the input to the output of this ring. And as we switch it around, so 1 includes 1 resistor, and then 2 resistors, 3 resistors, and then 4 resistors. And then it switches over to a 500 ohm resistor. So there's an interesting arrangement here where the voltage comes in through the 500, goes through this ring, and then to the output. And now from now on, as we swing around, we have 500 goes across here. We have an extra 100, giving us 600 ohms, 700, 800, 900, and then back to 0 again. So that's pretty clever. But one thing you can see, I think it's clear, this is just plain copper. So as we turn this around and rotate it, it slowly scratches into the copper. Now, someone pointed out on the EEV blog channel that nickel plating at home is actually quite straightforward. So I thought, fantastic, why don't I buy one of these, and then we can try some nickel plating and see if it improves the durability of the copper. So the only other interesting thing is the actual construction of these buttons. So it's got a nice clicking thing here. That's probably really annoying in the audio. I hope I'm not deafening people by clicking right in their ear. But if we unscrew this, it's actually an amazingly simple mechanism. So that should unscrew that. And now this knob should come off. And what you can see is there's just a small ball bearing on a spring. Now, I think that's visible. And on the underside of the switches, there's just little divots where that ball bearing slots into. So when you have this pushed down, it clicks around quite nicely. So that's a really neat, clever construction. Obviously quite cheap as well. And here's the horrible grease that I got all over my fingers when I first took this apart. So what I'm going to do, I'll take that out now. I'm going to remove this PCB and I'm going to try nickel plating it, and then we'll see what happens. So I've removed the PCB, and I'm sure you've all been shouting at the screen going, "You idiot, it's never going to work. You want to use electroplating to get nickel onto this, but you've got all these resistors." And I think you might be right. That is going to be an issue.
One eternity later.
Well, that's an hour of my life I'm not getting back. But I've soldered jumpers over every single resistor, so now everything should be connected. So that's pretty good. We should get current going to everywhere. So this should plate nicely, I think. So I'm now going to try and create some nickel plating solution. So I have this this nickel strip. It's not ideal because it's quite thin. I think ideally you should have something quite thick for your electrodes. But I put a negative electrode around the edge of this bowl, and I've got a positive electrode going in the middle. And this is all sitting in a bath of white vinegar that's 5% strong. Now I've got my power supply here, so I can control the voltage and the current. Now there's just a couple of things. Reading it on the internet, we should add a bit of salt to our solution to make it a bit more conductive. So I'll sprinkle a bit of salt in. That should do. And apparently you can add some sugar as well. So apparently that acts as some kind of brightening agent, which should make our plating work better. Now I've seen a few people saying it doesn't really work, or you need to actually do some experiments, but we'll sprinkle a bit of salt in as well. So let's just stir this around, try and get it to dissolve. That's probably good enough for now. So what should happen is our liquid should turn a nice shade of greenish blue. So let's turn on our power supply, and then we'll turn the constant current up. Now I may have to increase the voltage to actually get any current flowing. So let's turn our voltage up. I've seen various things on the internet about how much voltage to use. Some people say very low, some people say very high for this initial stage. Now let's actually try and get some current flowing. So we've got 0.1 amps, 0.2. So I think we'll leave this about 20 volts, and let's just limit the current. So I will, it seems to be current limiting at about 0.4. So let's just bump that up a bit. So I'm going to current limit at about 0.5 amps. So we'll leave this running for a while. We can see some bubbles forming, so we are doing some kind of electrolysis. Hopefully our liquid will change colour. So I will check back on this in an hour or so and see what's happened. And there we have it, a beautiful emerald green. So what's gone wrong? Apparently this nickel strip is actually nickel plated steel, so that's not going to work. What I've produced is some interesting slightly brown liquid. Okay, we're ready to give it another go. I now have some proper nickel. Now I'm not sure why I was testing with a magnet before, because obviously nickel is magnetic. But let's unwrap these. I've bent these into this shape so I can put them into my bowl and connect the crocodile clips to these parts. So let's get the show on the road. So we have our nickel electrodes, and I have here my little power supply. Connect this to the positive, this to the negative. And now I need my vinegar. And once again, we'll add some salt. So a little bit of salt. Let's give that a little stir to help it dissolve. And we'll add a bit of sugar. Let's stir that as well. Okay, so let's put that there. Now I'll just plug in the power supply. Okay, so let's turn this on and see what happens. Okay, so our output is 66 volts, and our current is currently pretty low. So let's leave that at quite a low voltage. I think a low voltage should be better for this kind of experiment. I'll leave that running for a while and we'll see what happens. Now I can see some bubbles forming, so something is definitely happening. So hopefully we should get a nice green liquid this time. Let's see what happens. So that's worked pretty well. I ended up turning up the voltage to get more current going through the solution, and I've messed around with the position of the electrodes, but we've got a fairly decent, nice solution. It looks quite pale from above, but if I just move the camera down to the side, you can see we've actually got quite a nice colour. So I'm going to decant this into a jar and save it for later. So that's pretty good. So there's a couple of interesting things. Here's my nice nickel plating solution. It's a pretty nice colour. Very, very nice. So I think that's going to work well for our experiments. If you look in the bottom of the dish I was using, you can see a few specks of some material. So I guess our nickel electrodes aren't quite as pure as 100% nickel. It's interesting to look at the positive electrode. You can see that it's been dissolving away into our solution. So the corner there has gone quite rounded. It used to be a very sharp corner like this. So this is the side that was closest to the negative electrode. So that's been dissolved away. And on our negative electrode, you can see that it's been building up a coating of nickel. So that's also very interesting. So although we've got nickel in our solution, we have also been adding to our negative electrode. So this is also very interesting. I can basically scrape off the nickel plating from the negative electrode. Produces all these little bits of nickel, which are all magnetic as well. So that's quite cool. Collected all these little fragments of nickel. Pretty interesting. Well, hopefully our nickel plating will work slightly better than this when we try it on the PCB. So I thought we would start with a fairly simple test. So I have here a little coin, and I've got my power supply running on quite a low voltage. So I'm just trying it on around 2 volts. So let's drop this in and see what happens. I can see some bubbles coming off, which is a good sign. And what I've done is I've connected both of these nickel electrodes to the positive supply. So I think this is actually working. It's quite slow, but it's definitely changing colour. I think that's definitely worked. I might leave this in for a few more minutes, but our nickel plating solution is working nicely. I think that's pretty good. Very cool. Seems to have worked. Nice. I think we're ready to nickel plate our PCB. So let's give this a go. What's the worst that could happen? So it should be able to fit this in. I think if we go this way round, we won't short anything out. So this is very interesting. I can see bubbles all the way to here, but I wonder if my jumper wire here is not quite making contact, because I don't see any bubbles after that part. So what I might do is take this out and just double check that connection there and make sure it is wired up. Okay, we're ready to go again. Let's turn the power on. Now I can see on my power supply is about 0.1 amps going through, and I've got it set to around 2 volts. So hopefully we should start seeing some bubbles soon. Well, it's an interesting result, but it's not quite the result I was hoping for. It has kind of worked, so we do have some nickel plating on our copper tracks, but it's not worked everywhere. So for some reason we didn't get any nickel plating here. There's a few places where if you look closely you can see the bubbles were too much. I'm not sure why this area is black, but it's not quite worked, has it? More experimentation is required. Now you may be thinking, what a shame, the resistor box is completely broken. Well, not so fast. The guys at PCB have produced these PCBs for me. So I have recreated the exact circuit from the resistor box and got it made up. So I'm going to solder one of these boards up and we'll rebuild our resistor box. So one thing that is quite interesting is why it's not worked so well. If we look at this coin, it seems like it should have worked quite well. So I am wondering if doing it in that shallow dish just wasn't a good idea. I wonder if maybe having the PCB vertical in a big jar of the solution might have worked better. So I will definitely carry on some experiments, but in the meantime, let's get these new PCBs wired up and rebuild the box. So I've attached the original flying leads. I just need to attach these to the mounting posts. So let's put the springs back in, and then we'll put all of these back in the 0 position. And then we flip over, and of course everything drops out. So, very annoying. Maybe we should do this one at a time. So the important thing in the 0 position is that we have 0 ohms, which means we need to put these things this way round. So we come in here, we go around, go straight across, and we come out here with no resistors. And there we have it. So that will be 0. And then with 1, we have the 1 resistor. 2, 3, 4, and then 5, 6, 7, 8, 9, back to 0 again. So I'll quickly do the rest of these, and then we're back together. So there we go, back together. Now, you can already see, this is a hassle-coated copper. We're already marking this, so we'll see how long this actually lasts. But I do have quite a few of these PCBs made up, so no shortage of replacement parts. But let's see how this works. I will carry on investigating the nickel plating, see where I can get with that, and see if that makes any difference at all. But there we go. We now have quite a nice resistor box. I've got some nice binding posts here. I'm quite pleased with that. I think that's made a bit of adjustment on this one. Well, there's the hole, so we can put banana plugs through there. Maybe I'll spin these around to make them slightly more accessible, but not bad. My new resistor box is finished. I'm not sure what I'll do with this. It's probably destined for the bin, I think. Pretty much ruined. Although an interesting experiment. The nickel coating does actually seem to be fairly robust, so it's quite hard to actually scratch it off, he says, and then manages to scratch it off quite easily. But definitely a fun experiment. I shall do more of this and see where we get to. Yeah, fascinating. So I thought I'd give it a go with one of my PCBs. Now I'm not sure how well this will work, but I've soldered all of these jumpers on the back so everything is connected, and I've given it a good clean using isopropyl alcohol. So let's drop this into the bath and push it down to the bottom, and then we'll hook this up to the negative electrode. Unfortunately I used red wires. I should have used black, but that's fine, doesn't really matter. So I've got wires connected to both ends of the PCB, so that's hooked up to our negative electrode. I'm going to take my gloves off because they're a bit wet now, and let's turn on the power. So that was definitely interesting. So here's the PCB that was in the solution. I left it in for quite a long time, and I brushed off any bubbles that were forming, and you can see that it has changed colour quite a lot. So if we compare it to the previous board, this one's very shiny with the hassle coating, This one you can see we have a slightly more dull coating. Now I do think there may be some contamination in my solution, so I'm going to have to run this all again, but I'll get a much more sophisticated setup for that. So let's just do a fairly non-scientific test of the coating. So I'll just try scratching it. So it's not that hard. I'm not sure if that's really visible in the video. I've made some small scratches, but let's compare that to the original boards. I'll try and use the same amount of force. Well, that is interesting. Those scratches are much more visible than the scratches I just made on the coated board. So you can definitely see the scratches here compared to my coated version, where the scratches aren't actually very visible at all. So I wonder if my coating is actually working, or maybe it's just that this surface is not quite as reflective as this one. Very interesting. So I will definitely do some more experiments, but this video is now incredibly long, so I will stop here.